Given an array of integers nums and an integer target, return indices of the two numbers that add up to a target. Let's take an example for this. The given array is 8, 2, -2, 1 and 6 and the target is 7. By looking into the nums array, we can say 1 and 6 add up to the 7 and the indices for 1 and 6 are 4, 3 and 4 respectively. So we have to return 3 and 4 as a result. There are certain cases that are not mentioned here. What if there are no pair that add up to the certain target? The cases can be either the nums is empty or the length of the nums is 1 or the length of the nums is more than 1 but there are no pair that add up to the target. In this case, if the target is 8, then there is no pair. In these cases, we have to return -1 and -1 as a pair. What if there are multiple pairs that add up to the same certain target? In this case, if the target is 6, then the possible results can be 8, -2 or 2 and 4. In this case, we have to return either 0, 2 as result indices or 1, 3. Let's dive into the solution. Given nums array is 8, 2, -2, 1 and 6 of length 5 starting from index 0 to index 4. The given target is 7. We have to return two indices I and j that add up to 7. Let's take I as index 0. The element 8 at index 0 requires -1 to add up to 7. We'll search for value -1 in the rest of the indices starting from 1 to 4. We'll take index j as index 1. -1 is not equals to 2, so we will increase j to index 2. -1 is not equals to -2. We will go to the next index, j equals to 3. -1 is not equals to 1. We will move j equals to 4. -1 is not equals to 6. We could not find a pair for index I, that is 0, that add up to number 7. We will move I to the next index 1. The element 2 at index 1 requires 5 to add up to 7. We will again search for element 5 starting from index 2 to 4. As we have already searched for index 0. 5 is not equals to -2, not equals to 1 and not equals to 6. We could not find a pair for index 1 as well. So we'll move index I to the next index. Now I equals to 2. -2 requires 9. 9 is not 1, not 6. So we'll again move I to the next. 1 requires 6. Element 6 at position 4 adds up to 7 with 1. So 3 and 4 is our result. Let's code the solution. Here I have a method toSum that takes two arguments, nums and target, and returns one array. I have implemented few test cases to verify toSum method. I can invoke those test cases using this command. Right now all the test cases fails. Now let's start implementing the toSum method. First we will handle the constraints, that is we will return -1 and -1 when there is no target found. And the cases can be if the length of the nums is 0 or 1, that is less than 2, then we will return -1 and -1. Then we'll search for the pairs that add up to the target and we'll return them as we find. If we don't find any pair, then we'll return -1. Now let's search for the both indices I and j. So to search for I and j, we have to traverse the array twice. once for index I. So we'll traverse from start from index 0. We'll go until end of the array and we'll keep incrementing. And for each index I, we'll search a compatible pair, index j. So we'll again traverse j. J will start from one index more than I. So I plus 1, j will start from I plus 1 and go until length of the array until the end, and we'll keep incrementing j. Then we'll check if both indices add up to the target. Nums of I plus nums of j is equals to target. Then we'll return I and j. You don't require to go until the end, that is till 3. So you can traverse I until length of the nums minus 1. Now let's check if this solution passes all the test cases. Okay, few test cases failed. Let's check that. Okay, we made a mistake. Instead of incrementing I to nums.length minus 1, we accidentally did it for minus 1 j. So we'll just redo the changes and check. Well, this passes all the test cases. Let's analyze the space and time complexity of this program. We can analyze the time complexity of a program by looking at the for loops. Here, two for loops are used. The first for loop for index I is starting from index 0 and ending at length of the nums array. If the length of the nums array is n, then this loop will iterate for n times. So its time complexity is order of n. Similarly, the second for loop for j is starting from index 0 and ending at length of the nums array. So its complexity is order of n as well. These both for loops are nested. So combining these loops, it will iterate for n square times. So we can conclude the final time complexity of the overall program is order of n square. There are no extra space used that depends on the length of the nums array. So the space complexity of this program is order of 1. Let's optimize the solution. We will take same nums array and same target 7. We will have one hash map. Searching any element in hash map is O of 1. We will take one index I and we will start from index 0 and go until index 4. We will start from index I equals to 0. Element 8 at 0 requires minus 1 to add up to 7. So if any element after index 0 is minus 1, then it will require index 0 to add up to 7. So we'll save minus 1 requires index 0 to add up to 7. We will increment index I to the next element 1. In our hash map, there is no key 2. So till now we don't have a pair for 2. 2 requires 5 to add up to 7. So similarly, we will save any element 5, the pair would be 1. Then we will increment I to the next index 2. Checking hash map, there are no pair for minus 2 as well. Minus 2 requires 9 to add up to 7. So the pair for 9 would be index 2. We will increment I to 3. There is no pair for 1 as well, and 1 requires 6 to add up to 7. So the pair for 6 would be index 3. We will increment I to the next index 4. So by looking at the hash map, we can see the pair for 6 is index 3. So the result would be 4 and 3. Let's code the optimized solution. First we will handle the constraints. If length of the nums array is less than 2, that is 0 or 1, we will return pair of minus 1. Then we will search for result pair. To do that, we'll first initialize a empty hash map. Then we'll start iterating over the nums array. We'll take index I equals to 0. We'll go until length of the nums array and keep incrementing I. Then we'll check if element at index I is already in the hash map. Then that would mean that element has a pair. So we'll check if hash map has num at index I, then we would return index I and the pair of that element at I, that would be hash map, and we will get the value for the key nums of I. If element at index I is not present in hash map, then we'll set target minus nums of I as key and index I as a value pair. If we don't find any pair that add up to the target, then we'll return pair of -1 as result. Now let's check if this solution passes all the test cases. All the test cases are passed. There is only one for loop. It is of order of n, and retrieving any element from hash map is order of 1. So the overall time complexity is order of n. And here we are using hash map as an extra space, and this hash map is directly proportional to the number of elements in the array. So the maximum length of the hash map can be the length of the nums array. So here the space complexity is order of n as well. Time complexity is O of n and space complexity is O of n.